to Nathan is Dr. Sotirios Stadiopoulos, who is a physician executive and the president and CEO of E2A Pharmaceuticals. And again, his company is involved in artificial intelligence. So that's just briefly. There have been 4 industrial revolutions. The first one was in the 18th century, and that was mechanical production. The 19th century was the second industrial revolution of mass production. In the last century was automation. And in this century, the 4th industrial revolution in the history of the world is artificial intelligence. It has been the subject of discussion in science and science fiction for decades. It is, at least in what I do for a living, become pervasive. And it seems to be creeping into, and I don't mean that in a negative way, in everyday lives. We may be years away from general artificial intelligence, but narrow AI has been being implemented very quickly and is already having a widespread impact in lots of industries that our panelists will refer to. For example, in the medical industry, AI is being used in colonoscopies as a diagnostic tool. And statistically, it is proven to be 20% more effective and accurate than doctors. Pharma companies have millions of patient years of clinical trial data that can be used in the healthcare space. But it'll be interesting to see how it plays out over the next, I'd say, 10, 20 years. 2 years ago, there was a report by McKinsey that suggested that AI could replace as much as 30% of the world's human labor by 2030. A recent MIT study indicated that even jobs that are not replaced are likely to change substantially as artificial intelligence develops to perform more tasks and requiring a significant restructuring across most industries. And then there are the social and ethical issues. How is AI being implemented? The consciousness of bias in the algorithms. People are thinking about addressing these issues. There have been incredible advances over the last couple of years in facial recognition software. That is not only being used by law enforcement, but by private citizens and companies. And the issue is going to be, as our panelists will talk about later, is this a utopia or a dystopia? Anyway, to give us some context, I'd like to ask whoever would like to take up the question, if you could briefly explain how machine learning works and the roles of deep learning and neural networks in creating AI.
So I'd like to thank my colleagues for just watching me pick up the microphone. Actually, in the healthcare sector, I can speak mostly for healthcare. There's been a lot of work that's being done in AI. The issue with AI that we have is there's 2 aspects of AI that always pop up. Number one, do we believe it yet? Do we actually think it works? And number 2, who really knows on how it works? And what do the networks actually look like? Are they useful to us right now? And do we have enough information to be able to put in there so that we actually get some sort of machine learning? I think, James, you alluded to pharma companies, which is closer to my heart, having millions and millions of data sets or patient data that they can actually incorporate. But what we find is that not all the data is actually useful, number one. Number two, the ability to actually use all this information is still limited to only a certain amount of companies that have capabilities to do it, because that's still a challenge where not everyone's really AI able yet. And three, I think one of the most important things is the translation of what we get at the end of it, which for the most part, we're still having difficulty in seeing how that translates to something that's actually tangible and usable for patients and obviously our end users, or whatever that may be. So that's from the aspect of healthcare in a quick nutshell. I'll leave it up to my colleagues here to add on to this.
The way I think about AI is really replicating what we do as humans. So there's a couple of things, key things that we do. We read, we write, we speak, and we listen. And so these are the things that we train artificial intelligence to be able to do. And kind of putting together these capabilities is really what it's all about. So what is the difference between a regular program and machine learning? A regular program is kind of like running a script or a recipe, which you put all the ingredients in, and at the end of the recipe you get a pie. Now the difference with machine learning is it can start creating its own recipe, and the way that it does that is by interpreting the inputs and deciding amongst different variations which might be a good output. And in order to do that, you have to kind of train it to spot patterns in specific ways. And that could be, for example, training to find cats by saying, here's a bunch of cats, and no, this is a dog and that's a cat. And so it then learns over time, this is what a cat looks like. And so the main applications of machine learning and artificial intelligence are really around recognizing images. Think of self-driving cars, think of image search, machine translation, translating between different languages, and then of course everybody's got Siri or their voice assistant, Alexa, so kind of taking that audio sound, hearing it, and then interpreting it and feeding it back to you. So that's how I think of machine learning data.
Great descriptions. So I also teach data science as an adjunct at UC Berkeley. They have an online master program in data science. So a lot of the machine learning, to demystify it, is very grounded in statistics. And a lot of us in the room, I'm sure, especially financial services and other areas, have studied statistics. And machine learning, kind of in the windows that you have, as both of you said, lots of inputs of data. And when people talk about supervised machine learning, it's when the input or the training set of the data have labels. So think about this room, you can label the light, you can label the chairs, you can label the gender of the attendees, the width and length of the room, etc. And you put that into an algorithm, and it can extract features or give you outcome that you desire. So that's supervised learning, machine learning, when the data set is labeled. And we hear about unsupervised learning is when the data set is not labeled. And that goes to kind of your example of recognition of images when you use neural networks or deep learning, where it learns the representation of data, such as a picture of a cat, and it learns how to reduce the noises of the background, of the trees, or the piece of furniture in a room, and just identify the pixels and representation of the cat. And then you will learn to generate similar images, and there are different ways to understand the errors generated of each of the images and so forth. So, but the simplest example for those of you who study statistics, regression is supervised machine learning. And a lot of us understand regression, whether it's single variable regression, multivariable regression, logistic regression. A lot of us use those. that's actually machine learning. A key difference, as you described, is that now there are tons of libraries, lots of automation that allow not just statisticians, but also engineers to apply those at scale.
Thank you. Artificial intelligence has been talked about, for literally decades, but the development and implementation has really seemed to increase exponentially over the last few years. And I'd like your thoughts as to what has changed to cause this swell now in terms of implementations as opposed to, say, 10 years ago. Nathan?
Sure. So I think that today the computers are a lot faster than they were just 3, 4, 5 years ago. So the processing power means you get a much smoother experience as a user. It also means that when you speak to Alexa or Siri, she responds quite quickly. So that's just like, in a nutshell, like the speed plays a big role in your experience of it. Now, when it comes to information work, so I know there's a lot of attorneys here, people in financial services, the ability to process documents and read documents and pull that information out. Initially, it was all about just being able to pull out a word and correctly identify that word. Now, that is kind of like the building block. And now you can layer systems on top of that to actually process the data for you, to do a lot of the analytical work that you would be doing, and automate a lot of that analysis. So as a lawyer, like think of a huge M&A documents or due diligence, things like that, you can effectively look for targeted phrases and just rely on the machine to be able to pull those out for you, and you just go to those key passages. That's one example. In financial services, you think of CRM systems where you might have a lot of customers or clients. In the past, or actually even still today, you might have like 5 different systems that you go to. One of them is reading about the relationship with the customer. The other might be looking at their portfolios or their investments. Another might be reading the content center, marketing materials, and maybe the news, right? So you have to read all those different systems, access all of them, to be able to figure out what you're going to say to that client. And also make it interesting and relevant for them. So I think now you've got systems that can enable you to read all of that information and then kind of just pull out insights for you and rank them and score them. So now, instead of going through each of those 5 systems for every your 200 clients, it's done for you across all 200 every day, and you only have to spend your time focusing in on the insights and not the underlying data. So this kind of brings a totally new way of working where it's an AI-enhanced workflow where you're just relying on that to surface what's relevant, and then you can use that to engage with your customers, your clients. So I think this brings exciting new possibilities for all of us in information work.
The financial world, and I guess the rest of the business world has actually seen advances. There is, when we talk about it in healthcare, there's a spectrum of healthcare that currently is actually doing quite well because of AI. Diagnostics-wise, radiology-wise, is where we see most of the biggest advancements. We have a huge repository of information. This is why colonoscopies were really pointed out, but it's not just doing a colonoscopy that's going to help you. Knowing in situations where there's multiple polyps in someone, and we know that there is a significance with having multiple polyps and the correlation with that with colorectal cancer. Imagine having to go in and finding in a colonoscopy as a physician about 200 different polyps. Are you going to biopsy each and every one of them? How do you know which one you should biopsy to know what's going on? What we're seeing now is, especially where the camera is actually able to focus and as they pass through, it shows a high probability of some sort of changes that have happened, allowing for the biopsy to be much more successful. And that's actually helped us a lot. But that's a lot of information that was gathered over the years to help us actually get to that point. Now move the spectrum over to pharma, as you mentioned before, that there's so many data sets that have come in because of patients that have been on trials for years. Imagine now that we could do even a phase 2 study, and for those of you who are absolutely clueless about that, it's just using your drug that you want on a specific patient population, and normally there is a control, right, which is a group that will get no drug or the standard of care, and then you compare. But imagine you don't need to actually do that arm. You know, in essence, what you have is you have historical data that provides you everything you need to know to make that comparison. So what you've done now is you've taken away time, which you don't need to waste on that study much more. Number two, more importantly, is you don't have to actually put people on therapy that they may not want to be on. And number three, you just cut down the cost of a study that could be anywhere from 20 million to 50 million down to about 10 million to 20 million. And that actually, in the long run, is reflective of the pricing that we see, especially for drugs today, which is obviously a very big issue. So there is, from the spectrum in healthcare, there are many examples that we can use that can actually give you enough information, but it really has been because of significant amount of data that's been collected over the years. And that's allowed us to be able to do this now than we could have done this 10 years ago.
Thank you. Joyce, the next question's for you. It seems clear that AI is going to have a pervasive impact on societal developments. What are some of the interesting applications of GAN, generative adversarial network?
Okay, so you may have read the article in New York Times, I think last year. I think a group of data scientists in France actually use this technique of GAN, generative adversarial network, to generate art. Use machine generate art that look like Van Gogh or Monet and so forth. And they were able to auction that off at Christie's in New York, and they were able to actually get a good chunk of money. And that is, again, is something that you will read more and more in the press if you haven't read already. It's unsupervised and supervised machine learning, where a set of data sets is used to create the image. And then there is a parallel algorithm that is a discriminator, meaning use the parallel algorithm to tell the first algorithm how far off the image is compared to an image that will be recognized by human eye as it's a cat, it's a house, it's a Monet painting, or etc. And this has a lot of applications, and it relates to the development, as Jim, you asked about in the last 10 years. One is, you may also have seen people using GAN to generate celebrity faces, images, right? Or YouTube videos, and that has implications in terms of advertising, political ads, etc. Much have been written in that arena, and whether or not it's ethical. But more interesting use case is using GAN to generate one digital assets. So, such as art. How do you use existing physical assets or assets we see as humans we have, and use those images to generate digital assets that people can trade, potentially as a security or not as a security, but get a piece of the value, and let that exist in the digital world. It's quite fascinating because the asset's generated machine, but it's based on a real asset. The other application, actually a group of students is working on this, is using generative network to create images that could be gender neutral. Right, so all of us have cognitive biases with respect to particular products that are more female-oriented or male-oriented as you go into different product categories. What if you can actually create gender-neutral products in the consumer space, in CPG, and industrial, and create sustainability, reduce waste, but eliminate the bias from product designers, rather using machines to help with that product design. So I thought that was interesting, and it might inspire some relevant use cases in your minds.
Thank you, Tris. Nathan, you had alluded earlier about different AI tools, and maybe you can elaborate on how they've changed the nature of information work.
Sure. I think, as I kind of mentioned earlier, this ability to think about work in terms of man plus machine is really key, and it's really about kind of reskilling people and also providing training around that as to what that means. And so, as the field expands and AI becomes more a part of the everyday, increasingly people are good at relationships, people are good at context, and machines are good at processing a lot of data, whether it's structured data like numbers or transactions, reading news, kind of sifting through information. Machines are good at doing that, but they're not at all good at trying to figure out how that might be applicable to somebody and why it's applicable. And so I think the future of work is really about understanding the strengths of both systems. Whether you're a human, how can you kind of just get past the whole need to read every single number, to read every single article, to go through everything like bit by bit. You don't need to do that anymore. And you can, of course, dig into data if you want to, but much better if you are freed up to spend more time with clients, spend more time with the customers, spend more time interacting with other people with much better data and information, so that when you are interacting, there's a deeper connection and it's more meaningful to the people on the other side, your customers or your clients. And that goes for whether you're directly interacting with people or you're actually creating digital experiences that are kind of projecting that information in a way that's meaningful. So I think that this is a new way of working, and I think there's a lot to be gained from this approach.
Thank you, Nathan. So Tedious, we talked a little bit about the uses of narrow AI in the healthcare and pharma industries. But the question I have for you is, what ethical issues does AI present that are especially relevant in your field?
So let's just say in the medical field in general, I think, imagine this, we have enough data from an intensive care unit indicating how patients that have been either intubated, on ventilation, have been treated for months, and all that information is now piled into a certain data set that has been fed into a machine. At what point do we allow machines to start dictating what sort of patterns we should use based on how we see the patient faring and advancing along the way? DNR. Anyone know what DNR is? Do not resuscitate. Will we let a machine actually make that sort of decision at the end? How does that work? There's some questions that I think that we still need to think about. Medicine happens to be a little bit more about a sensitive issue, and I was talking to our esteemed panelists here before. There's a human component to medicine that will be very difficult to be able to replace. People look to a physician one way or another for the issue of care, but beyond just what the medical treatment will be. I always remember a professor of mine who said, you know, the weirdest thing, he had a patient came in, complained of cardiac pain or chest pain of sorts, and really there was nothing wrong with them. And as they're leaving, they're still sort of slumped over. And they say, you know, I have an issue with my son. You know, it just turned out to be that it was some sort of depression, some sort of anxiousness that was causing these symptoms. When do we stop having that human interaction sort of be part of the key of making these diagnoses? Will a machine learn enough to be able to pick up on that? And I think that's where a lot of our worries are. And I can say myself, and I use artificial intelligence in my work. I'm in biotech, and it's great. It teaches us so much. But then when I look at the aspect of actual medical care of humans, there's a part where I always feel there we can't let go 100%. We'll find ways to incorporate it because the data is important, right? I mean, we need it. But how do we use it, and what does it replace is really still up to us in a certain way. Now, staying away from the, you know, very drabby note of this situation I spoke about before, there's other aspects in pharma, like what I use, where I can see a lot of the data that goes in. I mean, the past 10 years in pharma, we've come up with drugs in cancer especially called TKIs, tyrosine kinase inhibitors. TKIs have been sort of the mainstream of precision medicine and really looking at precisely where to hit certain areas of cancer. So we've gotten over, I would say, 300,000-400,000 patients worth of data. That is incredible data to use, especially we use it when we look at properties that are important to be able to make a drug, right? Is it going to be absorbed well? Is it going to be toxic to the patient? Can it be actually long enough in the patient that it'll work? Will it destroy the patient's liver in the meantime? That's information that's very useful for us, and I think that's the sort of help that we need, and much more of that. But I think we'll figure a lot of that out as we go. There is a one-off, as I say, in medicine. Maybe I'm wrong. Maybe there's other aspects of it as well in other areas that will see some sort of resistance, because there's certain aspects of it that if you can't humanize it in a certain way, I don't know how as well will it be accepted in mainstream and communities.
Yeah, and just kind of add on to that, I think in many countries they face elder care, right? Elder care, it's a huge challenge. You don't have enough resources in nursing homes or even care for the elderly, making sure that they're okay and providing that emotional support. Tons of robots have been developed, right, and using AI, but they don't really replace the human element of providing care. The other area is education. So again, tons of investments have gone into providing, remote teaching and understanding how kids learn, recommending curriculum. But again, that teacher-student interaction and deliver that pedagogy in person is quite different from teaching a robot to do that. It's very difficult.
You bring up a great point. We now have, it didn't happen when I was in medical school, but we now see telemedicine as an option, right? Where a doctor can't go to every physician, but they have the ability to see them through a screen and feel that they're seen. They did studies of this to see if patients actually felt they were seen by someone, and it was not. It was pretty much like a phone call. To them, it was just the same. So there's a certain aspect of this that I think we still have to tackle and find ways to improve on. But I don't know, at least at this stage, how much of that will be overtaken.
I guess we'll see. Related to ethical questions, you pick up I was going to say, I'm old enough to say you pick up a newspaper, but you open up your phone in the morning